Today, I wanted to go over the concept of unary and ternary relationships in ER diagrams. Okay, now when you have an entity relating to itself, it's called a unary relationship. Here, what we have is two instances of the same entity participating in a relationship. It's also known as a recursive relationship. Okay, it's not very uncommon to have unary relationships, and an employee has a supervisor who is also an employee. So employee instance relates to itself. A component is made up of subcomponents, and subcomponents are also components. So you have a relationship of a component with itself. A course may have many prerequisites, and so which are also courses. So we want to make these relationships as part of our model, and to do that we use unary relationship. Okay, and so we have seen examples of unary relationships, and we will then go on to the next one of ternary relationship. Okay, all right. Okay, next is we're going to look at what we call an attribute of relationship. Attribute of relationships are very common too, and a lot of times whenever you have a many to many relationship, there may be an attribute that is part of that relationship. Okay, what does that mean? That means for a given combination of the key attribute values of the entities, there is one value of the attribute of the relationship, which means let's take an example. Okay, so a many to many relationship between recipe and ingredient, and each recipe belongs in many ingredients. I'm sorry, each recipe has many ingredients, and each ingredient belongs in many recipes. But the quantity of ingredient to go in a recipe, that is that needs to be recorded. Now, so the quantity, cannot be part of ingredient, and it cannot be part of recipe, but it's a part of combination of recipe and ingredient. So that is an example of uh, an attribute of a relationship. Okay. Next, we look at ternary relationships. Ternary relationships are relationships that relate three entities, and these are, of course, less common than binary relationships. Now, the what ternary relationships mean is that the relationships between any two entities depends on the third entity also. In other words, the binary relationship any between any of those two entities is not independent of the third entity. So we need to include all three together at the same time. And say, for example, we would like to keep track of how much an employee used an equipment by each project, then that usage becomes internal relationship. Okay, and now, of course, how is this done? Okay, so each employee uses many equipment, and each equipment is used by many employees, but we want to keep track of which project is it's being used on. So the usage becomes an ternary or three-way relationship. Okay, now we'll take a look at some sample problems, and this these sample problems will help us clarify unary and ternary relationship as well as attribute of relationships. Okay. All right, here we have a new problem here. So recipes database problem, and here it says we used to keep track of database for maintaining recipes. Information about recipes include dish name, cuisine, number of servings, and also like to record which other dish a particular dish may pair with, and also information on allergy and so on. In addition, we for each recipe we have a number of ingredients. Information about ingredients include name, description, form, storage requirement, and measure units. And the same ingredient may be used in multiple recipes. And for each ingredient in a recipe, we need to track the quantity used. So let's go ahead and build a your diagram for this. So let me go ahead and use Visio, and let's create a new EML, I guess, database diagram. Okay. So for this problem here, okay, so we wish to record. Let's go ahead and create an entity. So this entity is for recipe, and let's give her a ID as a primary key attribute, and we have name, cuisine, number of servings, allergy information. Now we also want to keep track of what other dish this recipe pairs with. So that's going to be a binary relationship of, okay, so we have pairs with. So a recipe pairs with other, more arrows. A recipe pairs with many other recipe. Okay, so let's go end arrow. We can assume a recipe pairs with um, one other recipe. Okay, so 0 or 1, and so pair is 2. So it may or may not pair, but so this way we'll keep track of whether the recipe pairs with another recipe or not. So it's a binary um, one-to-one sort of a relationship. All right. Now the problem also says that we have ingredients, and so ingredients are going to be our ingredients could be our next entity. So let's go ahead and create ingredient ID. We have name, description, form, name, description, form, storage, increment, and measure units. So next what we need to do is we need to set up a relationship between recipe and ingredient, and each recipe will have many ingredients, and each ingredient belongs in many recipes. So it's a many relationship between recipe and an ingredient. And so the begin arrow type is going to be many, and end arrow is also many. Okay, all right, so it's many, and let me make this a little fatter so it's easy to spot. Okay, there you go. And each now we also want to keep track of quantity to be used. The quantity is not something that belongs to a recipe. It doesn't belong to an ingredient, but it belongs to the relationship. So this relationship, I'll just call it has relationship. And so the attribute of the relationship, I'm going to simply use uh, okay. Quantity is the attribute of the relationship between recipe and ingredient. Okay. In addition, we also want to keep track of steps. Each step, there are many steps a recipe has, and so we'll create another entity called steps, called step, and ID. And each step has sequence number and time taken number taken. And some steps can be done in parallel. And so if a step can be done in parallel, we like to record which other step can be done in parallel. So which means we need to have a relationship of step with itself. Let's make this line weight and line. So this line will have begin arrow. So each step may have many other steps that it can be done in parallel. Okay, and it may have for each step there may be many other steps that can be done in parallel. Okay, so it's 0 to many to many. All right, so okay, there you go. And also each recipe has many steps, so there is a relationship between recipe and step. and the begin arrow is 1 because each step belongs to a recipe. The end arrow should be many. All right, so that takes care of the relationship between recipe and step. So this way we have seen example of um, attributes of relationship and also unary relationships. Okay, let's take a look at another problem. Here we have students take classes at Murray State. Each student enrolls in many classes and each class has many students in it. For a given class, a student has one letter grade. Okay, so how do we model that? So we'll pick an entity called student entity, and I'm not going to worry about filling in the key attribute and the other attributes. Okay, just for demonstration. So we only focus on the entities and many classes. So class is another entity. So we have many relationship in student and class. And because each class has many students and each student may take many classes, and so line begin arrow type is many. Each class will have at least one student and each student may have 0 or more classes. All right, but then we want to keep track of a grade. So grade is not, that doesn't belong to the student. It does not belong to class, but it belongs to the relationship between student and class. So we'll model that here. Grade is an attribute. Now this relationship, I'll call it X. Okay. All right. So that is an example of a attribute of a relationship. Okay. Similarly, the next problem, a project uses many equipment. Equipment is used by many projects. Whenever an equipment is used for a project, the time used is updated. So it's going to be very similar to this one. And so instead of student and class, we'll simply keep track of equipment and project. And this is the number of hours used. Equipment used in many relationship. All right, that's the equipment usage. Now you can think of a list of attributes and entities for to model basketball, statistics. And so I will leave that as an exercise for you to try and find. And we'll want to keep track of which team plays what game. We like to also record the players that belong to teams, and then you can see where the statistics and information will go into. Okay. Next question deals with the construction company has equipment and employees are qualified to work on each equipment. For billing purposes, they want to keep track of which employee used which equipment on what project. Okay, so this next problem has to involve 3 entities. So let's go ahead and do that. Project and and equipment. So a ternary relationship involving three entities, and unfortunately in Visio it doesn't have a three pointed line, so I'll have to make do with you know um, with some kind of a binary relationship here, but make it look like ternary. Okay, so this one, um, make it line arrows. So each employee may use many equipment. Given an employee and a project may use many equipment, and so it's many to one. It's many to many, and the end type is also many. Similarly, for each project and an employee may use many equipment. All right, and then we want to keep track of um, the number of hours each employee used it. So we do an attribute of the relationship, okay, and also we have another relationship. Say the employee is qualified for each equipment, so there has to be a relationship between equipment and employee also, a separate one. So this relationship is qualified, and each employee is qualified to work on many equipment, and each equipment has many. Each equipment may be qualified. Each equipment may be operated by many employees. Okay, so let's call this qualified. All right. So here we have two relationships. This one is a ternary relationship. So I need to make it up like that. Okay, there you go. All right, let's save this. All right. The next problem has instructor teaching courses that each section is taught by a faculty. Some courses are cross-listed. So if the courses are cross-listed, we want to keep track of it. So that's going to be a unary relationship. And the textbook used by each professor um, who teaches the same course can be different depending on the section. Okay. And so how do you model this? We have a relationship. We have an entity uh, E, and faculty teaches many sections. It depends on the section. So section is something that belongs to a course. So it's all that here. So the relationship between faculty and course is sort of indirect. It's through section. So we have to have a relationship between faculty and course, and another relationship between course and section. The same textbook may be used by more than one section. So the relationship between textbook and section is the next one. So relationship is going to be between there you go. Okay, so let's name this one instructor teaches, and section belongs to and textbook. It's getting crowded here. There you go. So textbook is used in. Right, so then you can figure out the cardinality of these relationships. So that's an overview of binary relationships with attributes and ternary relationship, and also unary relationships. Okay, all right, hope you found it useful. Thank you.